And the top one is the 5 plus. So if you type 5 plus the square root of 37, enter, divide by 2, that's this one, and 5 minus the square root of 37, enter or parentheses, or that fraction, you know, that alpha x key, then, and divide by 2. That's the 2 answers. But they're rounded. They're irrational. You can't do math frac on either one of those and get a fraction. You can't write irrational numbers as fractions. I'm sorry?
Which way do you want us to write it for the lesson? Okay.
We always do exact answers. Yeah. Much, much better. Number 3. 3m squared plus 4m plus 5 equals 0. Now, I can't look at that and just know. I mean, I could think about it. I know this has to be 3 and 1. I know this has to be 5 and 1. Is there any way, with them all being positives, would give me a 4? Probably not. Just thinking about them, because they're all addition. A is 3, B is 4, and C is 5. So we'll just set it up. M equals opposite B, negative 4, plus or minus big square root, or little square root, I'll say, all over 6, 2 times A. Okay, now I'm just going to tell you, your calculator's going to go a little crazy on you. Enter. Have you already typed it? 3, enter, 4, enter, 5, enter. Okay. Now, a lot of times y'all just say error, and you're like, oh, because that's what the old calculators will do. It'll just say error, I mean, the little calculators, but it doesn't always tell. Sometimes it tells you what your error is, but this tells you a whole lot about this problem. What does it say the error is?
It has to result in a real number.
Say it one more time.
Calculations must result.
Yeah, but tell me the top. What does it say up there at the top?
Oh, error, non-real answers.
Okay, so this problem has non-real answers. Well, what are the only numbers we know that aren't real? I. So they've got to have i's in them. And it says your calculator's in real mode and it can only give you real answers. So, and let me show you how you know that. I don't know if this shows up on yours or not, Hunter, but up there at the top, yes, I know it does this, but I don't know if this is up there at the top of yours. Ours says, let me pull it down a little bit. Do you see it says real? And yours doesn't say it. So you just have to kind of know that's what happened. Now, there is an issue with it if you're on the ACT or if you're on some kind of test. And I'll show you that in just a minute. But especially on ours, we can kind of see it. Oh, that's why it's not working. The problem is it's only going to give you these answers, only real answers right now. That's the default. I don't like it. I'll tell you about it in just a second. So we're going to go over. We actually could do it down here, but I'm going to finish 3 here. We're going to put the rule at the top of page 75, and then we'll do one more under the rule. So you need to write at the top of page 75 how to change to complex mode. What does a complex number look like? Remember? A plus BI. Remember that? Complex numbers? Keep that in mind. So the first thing you want to do is push your mode key. Okay. Do you see it? I think it's right next to second, isn't it? Now, I don't remember if we had to hit enter here or not. If it doesn't go, you may have to, if it doesn't kick out of your program. Most of the time to get out of programs, you have to do second quit, and then a lot of times you have to hit enter or clear because sometimes it still wants to spiral. Now, yours doesn't have as much as ours, Hunter, but a lot of this is stuff we don't use anyway. You may not even know that your calculator had the time and the date and stuff down here, but if it clears itself, if the RAM gets cleared, it clears that. It's not set like our iPhones where it's, in real time, like the bells and all that stuff. So I don't ever even look at that part. Some of this stuff is not that big a deal. But do you see real right down here? Arrow down to it. Okay. Arrow down to real. And then look right beside it. What's right next to it? Oh, A plus BI. So we'll arrow over to A plus BI. So I'll put arrow to A plus BI. Now here's the kicker. you look like you're in A plus BI mode, but it still says real, and that's because you have to hit enter to get it to go into complex mode. So enter, it now says complex. Now somebody asked me yesterday is how do we go back? And then my question is why would you want to go back? Because every number we know is complex, including irrational and rational. So if you've got it in A plus BI mode, it will do any arithmetic you want it to do. We've asked, when we go to these conferences, we ask TI, why don't you make this the default? So if some little 7th grader's doing his arithmetic on it, it says A plus BI, but it's going to work. It works for all real and irrational numbers, all real numbers, and all imaginary. So if your calculator gets cleared, RAM cleared, very likely it's going to change back. I think it changes back to real. So this is not one of those things that once you change it, it's going to stay there. Now to get out of this, some of them did different things. I know that second quit, which is your mode key, I believe will get you out of this. So second mode, yeah, and I thought that once we errored this, that we would probably have to go run the program again, but I think you can just hit enter and it comes right back. So let's redo this problem. Now it's still not going to be that pretty, but it's better than it was. It will at least give me those imaginary answers. 3, 4, 5. Okay, look. It's a little messy looking, but there it is. It's got the, see, there's your A plus BI form. There's the A minus BI form. Now, we want to leave ours exact. Now, if you remember your repeating decimals very well from middle school, that's 2/3. That's negative 2/3 right there. This is an irrational something, and I know that because of this number. So, our discriminant is negative 44. That is the correct answer, but is absolutely NS. The first NS, to simplify, is we need to talk about that square root of negative 44. So I'm going to do the factor tree, -1 times, because what do people forget? They forget the I. You got to remember, it's got an I in it. It shows you on there. And then, now probably on yours, Hunter, your screen doesn't hold as many numbers, and yours might have had ... out there at the end. It didn't show the I, but stating the discriminant lets you know that it was imaginary. That makes sense? Okay, so -1 times 2 squared times 11. So I comes out, 2 comes out. So we're going to rewrite this as 2i square root of 11. Now, I'm going to separate them. If you can reduce it, like I'll show you. So if I have -4 plus or minus 2i squared of 11, I know Ms. Newberry encourages you to separate it. You can put the 6 and reduce it. I'm going to separate them and reduce it because sometimes you still don't want to reduce right if you don't separate it. So just be careful. The -4/6 divided by 2/2, there's that negative 2/3, which is 0.6 repeating. And then plus or minus, and this 2/6 will reduce to 1i squared of 11 over 3. See, the 2 and the 6 cancel. Put them back together as one fraction if you want to, but the calculator separates them. It gives you, this is the negative 0.6 repeating. That second number in front of the I is the square root of 11, which is 3 point something, divided by 3. And that's what that is. Never ending, never repeating. The top one's the plus, the bottom one's the minus. Let's do one more. And it's more like number 2. I'm doing it more for that than I am the answer. So number 4 over here on page 75. I squared of 11 over 3. Okay, got it? Okay, number 4. N squared equals -1 minus n. Now, I kind of have to give you a little bit of insight to this one. My skill has always been to move everything to the side where the squared term has a positive coefficient. Okay, now think about what I'm saying. I would like the number in front of my n squared to have a positive number. Now, why does that matter to me? Because if I'm going to have to factor this, and especially if I'm sitting in a calculus, college algebra, whatever class, where the teacher will only let you have even one of these, just this, if they will, it is harder to do anything with factor a coefficient of negative. It just throws all that we've been used to doing. We're always used to factoring with a positive at the front. So, my habit is to do this. Now let me show you, and I'll show you both ways. With this problem, with the calculator, it won't matter. I'm going to move this over here with this. I'm going to move this over here. And I end up with, if you put it in standard form, n squared plus n plus 1 equals 0. Now, I did this for somebody yesterday, so I'm going to go ahead and do it. Is this wrong? No. N squared equals negative 1 minus n. You can write this down if you want to. Some people say, well, I'm just going to move that one thing over here. Minus n squared minus n squared. And so you get 0 equals, in order, negative n squared minus n minus 1. This one, 1, 1, 1. This one, negative 1, negative 1, negative 1. Same answer. But if I had to factor that by hand without the quadratic formula or whatever I'm going to use, it is harder to factor with a negative a. That's just my lesson. And because I've taught so many years without calculators, without graphing calculators, that's still, and when I was in high school, that's still a skill that I do. I just always get my a positive. I'm going to do it from this one. So we're going to let a be 1, b equal 1, c equal 1. Have you done it yet? And you get, and this one actually looks pretty good on the calculator. N equals, some of them don't look too bad. Some of them look pretty yucky. Enter 1, 1, 1.
Oh, that's a lot of numbers.
Well, their irrational numbers are always going to be a lot because your calculator has a big screen and because they never end, they never repeat. So there's no way they can show any kind of pattern because there's not a pattern with these numbers in front of your eye. So I had opposite b, which was negative 1, plus or minus the square root of negative 3, all over 2 times 1. Now, this one's easy cleanup, and I am going to separate mine. They separate theirs. I'm going to write negative 1/2 plus or minus. Now, what can I do to the square root of negative 3 to break it down? Yeah, going to take the I out. Negative 1 times 3 is the factor tree, and so I'll have I squared of 3 over my 2. Now, look at this and look at your answer. Look, there's the negative 1/2. And then the top one is plus. That number is the square root of 3 divided by 2. If you just go out of this program and type square root of 3 divided by 2, that's what you're going to get. And then the bottom one is the minus 1. So even though, and this is the feature that I really, really like, is because it has the discriminant. And when it does rational that are fractions, it doesn't give them as decimals. So it'll make it nice. It'll put 2/3. It won't put 0.6 repeating. Question? Okay.
On number 3, how did we get 6 as the denominator?
2 times a. Remember, your denominator is always 2 times your a. Let me go up here.
Oh, okay.
Yeah, and that's assuming we've done lesson 30, because that's why I like you to do 30 before you do 31. Okay, anything else? I'm going to cut off the